welcome to the Martian Colonist 5,000 subscriber special. So this will be a little bit different than usual videos that I make, where usually if I'm making an educational video or a Mars mission update, then I will usually research and then script that a few days in advance or so, and then record it in about 8 segments, and then put it all together and do all the editing. But today we're entirely off script, just here to interact with you, my subscribers. Because when I first started this channel, which was, that was over 2 years now, back in February 2014, we only had a few subscribers. It took quite a while to grow to 100, and in fact, just after one of my recent videos, which was my video on the speculation surrounding SpaceX's Mars Colonial Transporter, we actually went to over 1,000 subscribers. And so I realised that about 20% of my audience I haven't really had a chance to actually interact with you directly, ask you what kind of content you would like to see, and answer your questions. So that's what we're going to be doing today. I did want to start off though with a brief introduction about, well, who I am and what I do, for instance. So if you don't know me, my name's Ryan. I'm a PhD student here at the University of Cambridge. I work at the Institute of Astronomy. My research is focused on exoplanets, and more specifically on exoplanet atmospheres, which is obviously an incredibly exciting field at the moment, particularly now we have things such as the discovery of Proxima b, which I will be talking about a little bit later, because we're moving really to the stage now of going beyond just detecting planets, but really characterizing them. So, although I haven't talked that much about my own personal research thus far on this channel, I'll briefly talk about some of the things that I have been working on in the past year since I started my PhD. Now, all throughout this live stream, please send in your comments and your questions. I will be monitoring them. So you can see the easiest way in order to send me comments and questions is just over here on the right-hand side. So there's probably about a 20-second delay between me actually saying something and then you seeing it live. So, well, it's like I'm 20 times further away than the moon, for instance. So I can already see that you've been sending in some comments and questions. Wonderful, and I will be looking at each of them individually slightly later on, so keep them coming. Okay, right. So a brief introduction about myself and my research. So at the moment, what I've been doing, in fact, in the past few weeks or so, is writing my first author paper as a professional scientist working in exoplanets, because you spend a lot of the first year of your PhD just trying to read the research literature and bring yourself to the frontier of human knowledge, because you have to get to the frontier before you can actually consider how you can go beyond that. So I've been developing codes because basically what I do is I work on the theoretical side of astrophysics. So there's a lot of computer modeling involved in that. So basically what I've been working on is if you have a star and then a planet is aligned such that it passes in front of the star relative to our line of sight, then a small amount of the light from that star actually goes through the atmosphere of that planet. And imprinted on the light are absorption features due to the molecules in the atmosphere, which we can use in order to try and characterize the physical conditions in the atmosphere as well as its chemical composition. Most recently though, I've been working on some research that I actually conducted in the United States. Just in June and July, I spent about 6 weeks over at the University of California at Santa Cruz, where I've been doing some research to try and figure out when water will become visible in very cold gas giant planets. Because basically, when we look at Jupiter using a telescope, we can't actually measure how much water there is in the atmosphere of Jupiter. The reason for that is that at the really cold temperatures of Jupiter, which is about 125 Kelvin, water actually condenses and forms clouds at pressures about 4 times greater than that at the surface of the Earth. And so photons don't penetrate down that far very often, and so we can't see the signatures of the water. So I've been trying to figure out, if we have some exoplanets that are very similar to Jupiter, how much warmer would they have to be, or how different would their clouds or gravity have to be, such that we could actually detect water on these planets. And the reason why we're interested in doing this is because the amount of water on a planet tells you the environment under which it formed. And so there's been some interesting results over the past decade or so, in that when NASA wanted to get an idea of how much water there was on Jupiter, they sent a probe into its atmosphere called the Galileo probe. But the water abundance that the Galileo probe measured is substantially lower than our current theories of planetary formation predict. So either it landed in a very dry spot of Jupiter's atmosphere, which is basically the current consensus at the moment, or Jupiter is extremely depleted in water. And that means that our current theories of planet formation aren't up to scratch. And so that's why we want to be able to measure water in the atmospheres of exoplanets, many of which are easier to measure than the gas giants in our own solar system. So that's what I've been working on at the moment. I have a first draft of a paper done for that. And so we're just going through the various iteration processes. And alongside that, I've also been doing my own research. I do want to talk a lot more about exoplanets in future videos, though, because basically when you hear about exoplanets, you often hear about it in the mainstream media. And unfortunately, a lot of that coverage isn't done very well. One practical example would be the recent announcement of Proxima b, where even if you look at, say, the official press release on Nature's website, it might say things such as an Earth-sized planet has been discovered around Proxima b. And actually, we don't know the size of Proxima b. We don't obtain any measurements of its radius. All that we know is that how heavy it is, its mass, is at least 1.3 times the mass of the Earth. And that's a very important point to mention. It's not equals 1.3, it is greater than or equal to 1.3. It could be 7, it could be 8, so it might not even be a rocky planet, it could be gaseous. But I'll save a lot of that for another time because I want to make a dedicated video on Proxima b, where I will focus a lot more on how you could characterize the atmosphere of this planet. Because there were quite a few research papers that came out in the days following all the media coverage of Proxima b that the media hasn't really looked at. And so basically on this channel, I'm interested in communicating science wherever there is a gap, wherever the science is there but is not being talked about. A good example was my recent video on the Mars Colonial Transporter, where all the information that I used was in the public domain. It was just a little bit hard to find, and so popular science YouTube channels hadn't gone out and talked about the Mars Colonial Transporter, for instance. So that's the general idea behind what I want to do on this channel. Talking about areas in human spaceflight, planetary science, and occasionally in astrophysics that isn't really being covered, and do it at a greater level of depth than popular science, because I want you to actually take away some of the scientific ideas. Okay, so I'll briefly take a look at some of your comments and see what you're saying now before switching back. So let's see what you've been saying. Okay, so Horifia wants to know about the possibility of building things from Martian dirt. Now, of course, that is absolutely vital if we want to have a self-sustaining settlement on Mars in the future. A good example of research that could be applied here is what the European Space Agency have been doing, looking at ideas to effectively build moon igloos, where you use 3D printers that take the surface level regolith and paint it over a habitat in order to provide radiation shielding, for instance. So there's a lot more research that needs to be done on this, because obviously you can't ship all of your habitats indefinitely just from the Earth. You have to be able to manufacture them. Some interesting ideas would be if you can take the Martian regolith and then, let's say, just melt it, have some kind of Fresnel lens, for instance, that applies heat and then compresses it, then potentially that could build some kind of hard structures. How could we be prepared for emergency healthcare? So the basic idea for that is that you would have to make sure that in every crew on Mars, ideally at least half of the crew members would actually specialise in medical care, and you would have to have basic surgical facilities. So you could remove an appendix, for instance, but you wouldn't be able to, say, have open heart surgery or remove a brain tumour. There'll always be limitations. Your quality of life will always be lower on Mars than on the Earth, but you need to at least add enough redundancy that if your doctor gets ill, then you still have another doctor on standby. Okay, right. So where are we looking at moving forward? So with regards to videos that I will be releasing on my channel in the near future, most immediately I will be working on a video that should be coming out on the first Saturday of October, which is the 1st of October, so 2 weeks today, which will be my next Mars mission update. In this, I will be focusing on Elon Musk's upcoming Mars architecture announcement, although it's recently been renamed just in the past day or so to Making Life Multiplanetary, or How to Make Humanity a Multiplanetary Species, to be correct. I will also be coupling that with, there's actually a teleconference that will be taking place next Wednesday on the 21st of September, where NASA will be talking about how they are collaborating with SpaceX on the Red Dragon mission, which has been targeted for 2018, but, well, I mean, some of you know my thoughts on that. I highly suspect it will be delayed to 2020, not least with the unfortunate recent Amos 6 rapidly unscheduled disassembly. I hope it doesn't affect commercial crew too much, and SpaceX they're not really offering a timeline for commercial crew at the moment. The last we officially heard is that they wanted to have a test flight of the Dragon 2 in May of next year, but they've been a bit quiet about that since. So we'll see, and the latest on the Falcon Heavy that Red Dragon would need, for instance, has had it pushed back to 2017, targeting the first quarter of 2017. So we'll still see. Maybe we'll get an update in this teleconference. But I'll be combining that teleconference and Elon Musk's architecture announcement into one video, which I will then cover. And I'll probably also talk a little bit about Jeff Bezos' announcement, how Blue Origin is looking at having a Falcon Heavy class launcher. So all of that will be in my next Mars mission update. So after that, basically what I like to do on this channel in an ideal world is have one monthly update on efforts to extend human presence to permanently live on Mars, and any company or government that is working on making that a reality. But I also like to intersperse it occasionally with dedicated focus videos. An example of that would be my one that I made on SpaceX's Mars Pluto Transporter, on the origin of life. I also did a number of videos on how the Martian moons, Phobos and Deimos, formed, space radiation, all manner of different focus videos. So I would like to be able to produce one of those every 2 weeks, such that it goes Mars mission update, focus video, Mars mission update. But obviously, my time is quite limited with my PhD research, so we'll see. The next focus video that I would like to produce is one on terraforming Mars. So I've given a number of public talks before about this topic, and so it wouldn't take so much research to put this together. But when I make my videos, I usually try and put as many animations or videos or just simple images in there as possible. It was a little bit difficult to do that for the Mars Colonial Transporter video just because it was quite speculative. But for the terraforming video, there is plenty of things that I could use. I can also set up my green screen in my room here. Oh, and speaking of that, you might notice that I'm in a slightly different room than I have been for the past year. And that's because I've recently moved house here in Cambridge to a different part of the city. So I was actually doing that just as I was preparing to edit and release my last Mars mission update. So that was very, very hectic. But there's plenty of space in here, so I do intend to make some videos where I utilise my green screen, and in particular I would like to do that for the terraforming video. And there's all manner of wonderful animations and artist concept sketches we can use in that. So that will indeed be coming. I won't promise the date. Ideally I would like it to be out in mid-October, but we'll see, it could easily slip. I do also really want to make a video on Proxima b, as I've already mentioned, and I've had some plans for quite some time to make a video on Planet 9. Which the popular science media haven't really spoken about that much since the initial press releases, but there's been quite a few papers that have been published examining the probability of Planet 9 and where it might be and what its atmosphere could be like that hasn't really been picked up that much that I would like to explain and then focus on. If you have more video ideas, by all means please just drop them over in the comments over there. I will be saving a copy of those comments and then taking a look at them. So let's switch back to your comments for now and see if you have any other questions that you've been talking about. Let's take a look. Okay, so we have one here. Could I elaborate on the selection process and what sort of news can be expected from Mars 1 in the near future? So at the moment, the selection process is in the group stage. So we've all been tested as individuals, but they want to know how we work in groups. So most of us have already formulated our groups. We're in 10 groups of 10 scattered all over the world. And well, I mean, my group, I'm really pleased with my group. In my mind, it's really a science powerhouse, and I actually deliberately chose my group to be people that I haven't actually met in person to date. I've met over 30 candidates in person, but I wanted to get to know more candidates. So we've got a quite good international group. We speak on Skype or Google Hangouts relatively often. So we've been formulating those groups. About 90 candidates are now in slots in those groups, and so that's an ongoing process. So The most immediate news you'll probably see from Mars One will be surrounding various educational initiatives they've been working on. So I don't obviously want to jump the gun on that because that's all pretty much behind the scenes at the moment. I mean, I designed my channel originally so that I could keep you up to date with the latest news. But Mars One is usually quite... They want to make sure that when it comes to big news, that the news only comes out when they actually do an official press release. And so they keep all of us as candidates up to date. They regularly send us emails updating us on the process, and they're quite transparent about that. But as much as I would like to share more of the news that's actually going on behind the scenes with you, I'm pretty much, my hands are tied with regards to that, because all candidates agreed with Mars One to sign non-disclosure agreements such that they could let us know about all their funding process and what's going on with that. But be assured that the second that there is news that I can actually share with you openly, absolutely you'll see those in the Mars mission updates. Can I provide an updated schedule for when the first Martians will leave Earth? So we'll be able to do this a lot better potentially once we hear what Elon Musk is saying. It's been speculated that if Red Dragon stays on track for 2018, and then they get the Mars Colonial Transporter working by 2022, which is a ridiculously ambitious schedule, then you could potentially see humans departing in 2024, maybe 2025. I think that's overly optimistic. Mars One's current projection is leaving in 2026, but I also think that is incredibly optimistic, and that's what they might be able to do if they had their full, say, I don't know, $6 or $10 billion of funding instantaneously right now. Then that might be feasible. So my personal timescale that I would estimate for seeing humans actually departing to Mars for any commercial program really is I don't expect it to be any earlier than 2031. I would love to be surprised if SpaceX could pull it off in 2027, 2029. I would absolutely love that to be true. So I'll be keeping you all updated and I'll obviously let you know, but my personal estimate is 2031. Okay, let's switch back to the video itself. Okay, so I've talked about some of the videos that I would like to produce. So since my video on the Mars Colonial Transporter was one of my most successful videos I've ever made, it's had about 60,000 views now, and I would really like to thank everyone that's been sharing that and offering me good feedback on that. Please let me know if there's any other videos on SpaceX, rocketry or commercial spaceflight you would like to see, because I'd be more than happy to produce one of those. Okay, so what I'm going to do now is just focus on the comments that you've actually been sending in live. If it goes on for a very long period of time, we'll look at some comments that were sent in at the end of my last video. So let's take a look then at what you've been saying. So, can I show the battle station? Well, I don't know, the red and black colour scheme that I've got going on here with my computer chair, well, this is all just new furniture that I've been building, and, well, okay, fine. I'll show you something that I have, because I do actually have here a joystick and various equipment that I've been coupling with an Oculus Rift that I've just acquired for various spaceflight simulators and all of that, so, I don't know, maybe that counts as a battle station. Okay, other questions that you've been sending in. Do I think that China or other companies will get to Mars before American private companies? That was Austin that asked that. So, in short, no. From what I've heard, the latest plans that China has is looking at around 2040 or 2050 for Mars, and NASA is maybe still talking about the end of the 2030s. And SpaceX, well, and we know how they might be able to get around 2031 or even sooner. So I don't think that China will beat them. But China really strikes me as having a very sustainable approach. They want to go very slow, very carefully, and they're going to be focusing a lot of their resources on sending humans to the moon and establishing a moon base there first. And don't forget that China's budget is substantially less than the budget of NASA and the European Space Agency. So they're doing really good work. I was really impressed to see the launch of their second space station experimental module just a few days ago. So I'm quite optimistic for China's space program. But what I would really like to see is the United States relaxing some of their regulations that prohibit active collaboration in space exploration with Chinese scientists, which is often dictated by ITAR restrictions. Because, I mean, China has had a rover on the moon, for instance. They even planted a small telescope on the moon. And there needs to be more collaboration and sharing openly between different scientists around the world. So my personal hope is that if we see an international moon base established, that I know the European Space Agency is pushing really hard for, if the European Space Agency could rope in Roscosmos, China and India into this international moon base, then I would like to hope that America would then drop its objections to collaborating with China in order to be involved in this moon-based project. Because there are a lot of, say, American radio scientists who would like access to an experimental radio telescope on the moon, and they would only get that if they were willing to collaborate. So we shall see. Okay, let's see. Whoa, okay, lots and lots of comments that you have been sending in. Let's see, people talking about sound. Yes, the sound appears to be working. So, okay, a question from Victor, which I also saw submitted last week, which was the idea about having factories and building lines on Mars and when we might see those. Right, so I think that will take substantially longer than just the first few people going to Mars, because basically from day one you want to be self-sufficient in terms of your air supply, your power supply, your water supply, and you'd actually ideally have those stockpiled maybe a year or two in advance of actually the humans arriving. From about day 40 or so, then you want to be self-sufficient in food ideally, or just having backup food supplies if that's not possible. But with regards to actually having a proper infrastructure and industrial facilities established, that really requires major developments in 3D printing. I hope that those developments will be spurred and there'll be lots of innovation going on once we actually have humans on Mars. Because a big part of the struggle is actually creating the infrastructure and the architecture to get large amounts of cargo and people to Mars. This is being pioneered by SpaceX at the moment, such as with Red Dragon, where they're looking at landing 7 tons instead of just 1 ton, like we saw for Curiosity. But we would like to be able to have much higher payloads, like 30, 40, or even eventually 100 tons on Mars, in order to establish that kind of industrial architecture. So if I'm talking optimistically with regards to factories and building lines, I wouldn't really expect that till 2050, 2060s or so. But this could, of course, accelerate once we actually have more governments, companies, individuals that are actually able to get to Mars for relatively reasonable amounts of money. Okay, what else? A question from Jeff. What programming language do I use most often, and what would I recommend for focusing for STEM students to focus on? So, personally, a lot of the research that I've been doing to date has been coded in C++. Mainly that is for obviously interacting with legacy codes, but also that if you code in a low-level programming language like C or even Fortran, which I've used a little bit recently, then the codes run remarkably fast. And so if you have a time-sensitive application, then you want it to be able to run fast. One example is that I've developed models for exoplanet atmospheres that I need to run millions of times in order to sample the entire parameter space. And so I want the runtime for such models, I mean, it's not acceptable if they're a couple seconds or so if I want to run millions of them. So that's why I've been coding them in C++. When I'm actually presenting results and plotting them, then usually I will write Python scripts that will then take the results, the output of my C++ code, and then produce wonderful plots using matplotlib, for instance. You can also have Python wrappers that actually run executables that you've compiled in Fortran, for instance. So I would recommend a hybrid of a low-level programming language with a high-level one like Python for plotting. I actually learned C as my first programming language, and I think that it's much better to do it that way than learning a higher-level one like Python that actually hides a lot of the intricate details of how programming works behind the scenes. And honestly, you can learn C in about 2 days just by sitting down and just doing some exercises. But once you've learned your first programming language, it's easy to learn any other ones. So in short, C or C++ and Python I would recommend. There are also some experimental modules that I've seen written in Python. For example, there's one called Numba, that's spelled N-U-M-B-A, that actually compiles Python code on the fly in order to make it run as fast as C code. And I have been experimenting with this lately. So there's a lot of things that you can do, but in short, learn C and Python. That's what I would recommend. Okay, a question from SuperGecko8. Elon said that the MCT can go far beyond Mars and he is looking to rename it. Absolutely. I mean, just tell me, what is your speculation? What do you think the Mars Colonial Transporter should be renamed to if it isn't just going to Mars? And where else could it go? It would be very interesting to send people to orbit around Venus, for instance. If the MCT could deploy giant inflatable balloons in Venus's atmosphere, that would be fascinating. And there's a lot of research that would be great to do in the vicinity of Jupiter and Europa. but there is a huge radiation belt surrounding Jupiter, so that's an entirely other problem. And Callisto, one of the moons of Jupiter, is pretty much outside the radiation belt, so that could be fine. But we would like to go to Europa, ideally. But I imagine planetary protection regulations could cause some problems with that, because Europa, in my mind at least, is even more likely than Mars to have extant life on it. And on Mars we might see basic microbes beneath the surface, about 2 meters down. But on Europa, I don't know, maybe there could be alien fishes or something down there in the ocean near hydrothermal vents. And I remember I did an entire video earlier, actually, was it earlier last? It was, yeah, earlier this year on the origin of life, where I talked about how you can actually take the raw ingredients of life and spontaneously assemble them into living organisms. And all the ingredients on Europa exist for that process to happen. Okay, and yes, a lot of people seem to want to know about renaming the Mars Chronotransporter. I quite like the Mars Chronotransporter. I think that's a wonderful name. It conjures in my mind images of Battlestar Galactica, for instance, with all the colonial transporters and all of that. So I hope they still keep at least colonial transporter of some kind in there. I've seen some suggestions on the SpaceX Reddit page, for instance, that people would like it to be a planetary class starship. And I would love that. And oh, but that brings all manner of other questions, like how will people be trained in order to actually use the MCT? And whatever organisation does that, I mean, I spoke in my last video about the idea of a private astronaut corps to do that. I would really love it to be called Starfleet Academy, but we'll see. See, this is what's great about doing a live stream, because I can just ramble and we'll see where we go. Yes, my PhD is still on. It's going well. I had my first year assessment quite recently, so that's all been confirmed. PhDs here in the UK are quite short. They're much shorter than in the United States because we specialise in our education much earlier on. And so my PhD will probably be finishing around 2019 at the moment. Okay. Oh, so many questions. So there's been a lot of questions about how much money it would take to actually send various missions to Mars. And in fact, I remember seeing there was a very in-depth comment that James sent me last week, which was looking at how I believe that basically private companies like SpaceX can get to Mars in the time frame of 10 years, when NASA, with their vastly superior resources, would take 20 years. So, well, I mean, I would contest whether NASA can even do it in 20 years, maybe more like 25, because the issue is a lack of political direction, I feel. If NASA devoted all of its resources to Mars, maybe 10 years would be feasible. I mean, Robert Zubrin, the president of the Mars Society, has been championing that idea since the 1990s. So, I'll give one practical example. SpaceX's Red Dragon mission. The rumours are that they are spending about $300 million on that mission. NASA have said that if they were to do the exact same mission as a demonstrator, the cost would be closer to 3 or 4 billion. You're already seeing an order of magnitude difference there. So it could potentially be 10 times cheaper for a private company to do this because they don't outcontract all of their components, there's less bureaucracy, and in addition to it being cheaper, they can actually get it done a lot faster. I mean, a good example was SpaceX's return to flight following the CRS-7 explosion that took, rapidly unscheduled disassembly that happened last year, and they returned to flight about 6 months or so later. They're targeting at the moment that for their current return to flight to potentially return to flight in November, although that will probably slip slightly, maybe December or January, we'll have to see. But remember that following previous space shuttle disasters, NASA's entire fleet of space shuttles was grounded for 2 years. Private enterprise is more efficient. Someone did make a good point about how the Indian Space Research Organisation can do it for $75 million or so. So it doesn't necessarily always have to be the case that governments will be more expensive. So I'm actually very optimistic to see the low-cost missions that both India and China are pioneering. So my general thoughts are that private enterprise will actually be leading the frontier with regards to missions to Mars, but the exception to that is that I think China could actually do remarkable things on the moon, and India has very good science programs that are moving forward. So we'll see. It's really exciting times in space exploration at the moment. It's changed immeasurably since I started this channel 2 years ago, where people really weren't talking that much about human colonization and settlement of Mars. So yeah, let's just see how it goes. There's certainly going to be no shortage of what I can talk about in these Mars mission updates. Okay, other comments. So Carl asked if I could make a video about Skylon. I have actually made one about Skylon before. It was back in 2014. It was a video on, well, in fact, I could actually show you, because if I switch over to my window itself, if I go onto my YouTube channel, then so if you go into my videos on my channel, and then scroll down to some of the older videos down here, or actually, alternatively, I have a playlist. There is a playlist, let's see, there's one on SpaceX, conceptual design studies, orbital mechanics. Okay, I will actually have to go down there. So, where are you hiding, Skylon? Because here we are, the future of space flight, space planes. So, the video that I did on Skylon back then actually features an interview with one of the communications experts at Reaction Engines, which is working on Skylon, because they're actually based in South Oxford, where, because I actually did my undergraduate degree in physics in Oxford, and so I actually knew him quite well, and so I popped over to see Reaction Engines. That's actually where I acquired my own model of Skylon from. So there have been some updates since then. There's been a lot of both public money from the UK Space Agency and the European Space Agency, along with commercial partners pouring into the Skylon project. They want to have their first experimental Sabre engine having tests in about 2019. So potentially Skylon is still on track for the mid-2020s. So that I don't think there's enough new news for Skylon at the moment to merit a dedicated video. But if there is new news on that front, I will actually go ahead and then add that to one of my Mars mission updates. Because the Skylon project did actually do an extensive project review called Project Troy, where they looked at how Skylon could actually be used in order to do an absolutely ridiculous scale large mission to Mars. We're talking about 6 landings or so, driving hundreds of kilometers over the surface. I did talk about that a little bit in my previous video on Skylon, so I won't ramble about that too much here. A question from Thomas about what would you do during the 4 months of the Earth-Mars transfer? Would it be science projects or more recreation? So, firstly, a 3 or 4 month transit window requires a lot more energy than if you do the traditional Hoffman transfer maneuver, which takes between 6 and 9 months. So just to do that, you might need either a new engine technology or just more fuel, for instance. So, but if you did reduce it to 4 months, then a lot of your time would actually be spent doing exercise, for instance, because you want to mitigate against loss of your muscles and bone mass along the way to Mars. So potentially 3 hours every day would have to be devoted to that, unless you had, say, a rotating spacecraft connected by tethers. I know the Mars Society is very fond of this approach. Attach 2 capsules, have a tether between them, rotate them, and then the centrifugal force pushes outwards, and hence you get artificial gravity. So you could do that. Recreation facilities, absolutely. I saw some very amusing comments that suggested that the astronauts should basically be given the entire Steam library, which, I mean, that's an excellent suggestion. It would get a little meta if you had the first people actually going to Mars playing, say, space colony simulations like RimWorld, for instance, that I've been playing a little bit myself recently, or Planet Base. Actually, Planet Base I highly recommend. That's a very great game looking at settlements on Mars and icy worlds, etc. So I don't think that boredom will be a problem. I mean, I never find that I get bored. There's always about 10 different things that I could be doing at any one time. I mean, I would like to be making videos every week or so, but there's just not enough time with my own research. So, and in fact, one of the things that I would really like to be doing if I was going to Mars myself, because the journey to Mars and having people living and working on Mars in a permanently staffed scientific research outpost is one of the most exciting stories that will be told in the 21st century. And so this story needs to be told correctly. It needs to be told right. So just like the excellent work that Chris Hadfield and Tim Peake did on the International Space Station, I would like to use the scientific communication platform that I've been developing myself, and that's part of what I've been doing here on my YouTube channel, in order to engage the public, and particularly school children, and show them what it is like to live and work on Mars. Because that will be incredibly inspirational. And, I mean, I've spoken about this before, but there are so many huge problems we're going to face on the Earth in the 21st century. But those school children that are inspired by seeing people living on Mars will be the people who will grow up to become scientists and engineers who will go out and solve those problems. And indeed, even if they don't go into science, remember that as much as people often debate about this and say it's not true, politicians are actually humans too. Politicians go to school. They learn about science. If we can improve general science education such that the people selected from the population who become politicians have a better understanding of science, that will make our quality of life on the Earth as a whole better, and it will lead to something that I call evidential reasoning. By understanding the scientific method and basing all of your decisions based on evidence, that can only lead to better and more responsible decisions in the future. Okay, let's take a look at more of your comments. Okay, I'm really pleased seeing actually how many comments that you've been sending in. This is absolutely wonderful. Okay, so some comments that people have been sending. Let's take a look. So we've looked at the transfer. Am I confident that Mars 1 can put at least one of, will actually put at least one of the candidates on Mars? Well, remember that Mars 1 isn't an aerospace company. They don't actually build hardware. Their main responsibility is just gathering the money to pay established providers that can actually do that, like SpaceX or Lockheed Martin, and then actually training the people to do that. So I mentioned in my last video how I personally think the best way forward for Mars 1 will be to focus exclusively on the astronaut training aspects. Let SpaceX and Lockheed Martin and other companies focus on developing the hardware, because they're doing that anyway. You don't need to be paying hundreds of millions to Lockheed Martin just to do design studies when the work is being done anyway by SpaceX. And actually, well, I personally think SpaceX is doing a better job on that. Lockheed Martin, basically, Mars 1 wanted to contract Lockheed Martin to study how you could land 2.5 metric tons on Mars. SpaceX are going ahead with Red Dragon, landing potentially 7 tons or so. So that's not really that necessary anymore. So I think that if Mars 1 were to descope and focus on the astronaut training and establish a private astronaut corps that could then basically, various private companies or governments could then hire astronauts in the upcoming commercial space industry that we'll see, with modules like, say, Bigelow's space modules going up, then I think Mars 1 could actually train someone that could go to Mars. So we'll still see. It remains to be seen. We'll see. It's ongoing. I'll obviously keep you updated with what Mars 1 are doing, because I would obviously very much be in favour for them descoping in that manner. Okay, this is Sky saying that they have the same Hotas, which is the design that my Skylab right there is based on. Right, let's see. What are my thoughts on the giant mech battle between Japan and America? Well, I'm not sure mech battle going on. Yeah, I'm really not sure how to respond to that. As much as I like science fiction, because I'm a major science fiction fan myself, some science fiction recommendations, recent series that I really have to point out. The Expanse is an absolutely excellent hard science fiction series based on a number of novels, highly recommended. And it's set like in the 23rd century or so, but just in our own solar system, so not as fictional as Star Trek, for instance. And also Dark Matter, a Canadian science fiction series. I've very much been enjoying that recently. It really has a Firefly type feel to it. Okay, let's see if there's a few more comments that you have been sending in. Okay, look how much SpaceX has done in the previous 10 years. Okay, about Amos 6. So no one says, what do I think the refueling chains will be? Will NASA require for commercial crew? Along with that, obviously, how many customers? So it's probably best not to speculate on Amos 6 too much. The latest we've heard is that there's still not an official cause that has emerged as to what that is. SpaceX are obviously still pushing for a return to flight in November. We'll see about that. So yeah, I really can't speculate. What I would recommend, though, is there's an excellent video that Scott Manley has put together, which maybe I can post down in the comments or the description below if you haven't seen it, where he analyses the frames actually from the US launch report video that you've probably all seen, showing the rapidly unscheduled disassembly. So that's some of the best speculative analysis that I've seen. I do also recommend that if you're looking for the latest updates on SpaceX, then the best place to get them imminently is to go on the SpaceX Reddit page. There's only been probably 2 times where I've actually had news before I've seen it posted on there. So generally that's a pretty good source. Okay, other comments. Do I think artificial gravity is a must for the Colonial Transporter? I don't think so. Ideally, I would like to see that, but the issue is that artificial gravity has not been tested yet in space, and that's really surprising actually, because it's pretty well understood physics, centrifugal acceleration. So that would increase the lead time and the development of it. I think it's better just to cut the journey time down to 4 or 3 months, like Elon has proposed, and then just go there. You can investigate artificial gravity in future missions, for instance, but I don't think it's necessarily a prerequisite. Okay, a question from Cody of Codys Lab. Let's see. Playing planet habitation simulations whilst on the way to Mars, and I'm sure you'll make plenty of videos about that on the way to Mars, Cody. Unfortunately, Cody and myself aren't in the same team, as much as I would like to be on his team, although those will get reformulated as the selection process goes on. But great to see you here. And if anyone hasn't checked out Cody's YouTube channel, where he goes and does experiments, blows up things, highly recommended, definitely go check it out. Okay, we're getting to near the end of the questions now. So one final one that we have coming in from Jerome, I hope I'm pronouncing that correctly. What age should the astronauts be that go to Mars? So that's an excellent question. So it really depends on how much training is required. So, and yeah, you probably noticed that this is a little bit switching between multiple screens, and that's because I'm controlling everything here. I don't have a full production crew actually here, so well, I hope you don't mind the somewhat spontaneous nature of this. So, the age. For the first few crews, you would probably require at least 10 years or so of training, because there's so many different skill sets that you need to represent amongst all of those. So I've mentioned previously how you want about half of all people to be, say, trained in medicine, half in engineering. There's also things like dentistry, space law that you have to look at, exobiology, or probably astrobiology would be the more correct terminology there, looking at sequencing the genetic code of any potential either extinct or still existing today life on Mars. So the age, I estimate that probably people in their, say, mid to late 40s for the first few missions on Mars. I mean, I would obviously be quite young if I got the chance to go. If I started 10 years of training now, because I'm 23, then obviously I'd be 33 by the time I would be ready to go. But then most likely I wouldn't be selected to go on one of the first missions. There would then be various rotation cycles every 2 years when you wait for the next planetary alignment. So probably early to mid 40s I would estimate. Eventually, potentially, if you did have a private astronaut corps, maybe like the military style, you could have people who are incredibly gifted just after finishing university when, say, they're 21, being recruited into this astronaut corps, like how SpaceX occasionally recruits people directly out of MIT or Princeton, for instance. So then maybe you could see people in their 30s going to Mars after a period of training, and the training time period would likely reduce as you had more and more people and more redundancy on Mars. And there was actually a question last week about skill sets for Mars. So I mentioned a few of those, and I could certainly talk about that more later. Oh no, so now I noticed that a few people have noticed that Cody, the big celebrity, is here, of course. You know, there was actually a time, believe it or not, when I actually had more YouTube subscribers than Cody. So obviously it's my lifetime ambition to only get to the heights that Cody is at. Well, my near-term ambition that I would like to see actually is if I can get up to 10,000 YouTube subscribers. There are actually professional production facilities that YouTube has available in London near King's Cross, which is just a short 40-minute train ride from where I am at the moment, that people with 10,000 subscribers or more can actually book out for the day and then use. So if we can push up to 10,000 subscribers, then I would be able to improve the quality of my videos, probably record multiple ones at the same time. So that's part of my immediate term ambition. So we've got a few more questions coming in. Let's take a look. So people are still speculating about Elon's tweet about the MCT going beyond Mars. So maybe the moons of Jupiter, but people just don't realise just how far out that actually is. A Hoffman transfer that might take 6 or 7 months in order to get to Mars, you're talking 2+ years or so if you have direct insertion to Jupiter. So basically Elon will not be implying that there is some kind of interstellar capabilities or anything with this. We're a long way away from that. In my video on Proxima B, I will talk a little bit about potential interstellar probes that you could build and about the Breakthrough Starshot initiative, for instance. So I'll talk a little bit about that, but people, it's still a very long way away from that. I would like to hope that the Mars generation, the people that actively go out and start establishing a society on Mars, that will be really the catalyst that will inspire people to start thinking about wanting to go out there into the universe. But I mean, this is where a lot of my research comes in, because ultimately the long-term goal of my research is to look for evidence of life elsewhere in the universe. Whether I'm on Mars with a shovel looking for that, or what I'm doing at the moment using instruments such as the Hubble Space Telescope and eventually James Webb to look for evidence of life on exoplanets, we need to have a good target planet to go to outside the solar system, ideally in the 22nd century or so. It's no good if you don't have a good planet. Maybe Proxima B is a good one, but we need to characterize its atmosphere to find out, because it could be a lava world, it could be a gas giant, and if you're sending a mission that takes 20-30 years to get there, you have to know a little bit more about its atmosphere firstly. And so that's what I want to contribute to. And so we'll see. I'll obviously keep you updated about how my research is progressing on that. Okay, let's see if there's any final questions. Maybe I'll take, say, 4 or 5. So if you do have any more questions that I haven't addressed, please send them now. Okay, am I going to be spending some time out in a desert with my Mars One team, preparing and testing? So Mars One does actually have plans to have simulation outposts that would be in desert-like environments. They would want to have a few of them, so an initial one that would be quite low-key, probably in mainland Europe, for instance, that is for ease of access and training purposes. Then eventually you could have one like, say, in the New Mexico desert, similar to what the Mars Society has, or the Atacama, where it's very dry. But eventually you really would need to have a simulation outpost, and this doesn't just apply to Mars One, it applies to any astronaut training program. You would need to have a simulation outpost in Antarctica. Maybe it could be associated with one of the Antarctic bases that are already out there. And ideally people would spend about a year or so out there before going to Mars. So a similar way to this, that if you've read, say, Kim Stanley Robinson's Mars trilogy, then all of the people for the first mission to Mars on that actually do spend some time training in Antarctica. So I really think that would actually be vital. Okay, any final questions that we have? Let's see. What do I think of the Starshot project? Will it give us the first photograph of an exoplanet? I'll take that as the final question. So the Starshot project, yes, in short, it could provide a photo of an exoplanet. It depends. I mean, there's a lot that needs to be done. You need to miniaturize all of the technology, and obviously we've seen a lot of that. Just consider all of the technology which is in, say, an iPhone or a Samsung Galaxy these days. All that used to be inside a radio, a television, a computer, all compressed into one device. If the miniaturization continues, which I see no reason why it won't in the imminent future, then we could have wafer-scale probes that could potentially take photographs of exoplanets. You don't even need to actually go. I mean, there have been proposals that have been studied, missions such as the Terrestrial Planet Finder, for instance, which we're still a way off, that could actually obtain a direct image of an extrasolar planet where you could see continents and oceans and all of that without actually going there. You would need a large array of orbital telescopes, all piecing together an image via a technique called optical interferometry. You could also have these surrounding a crater on the moon, for instance, which is another reason why we need a permanently staffed science outpost on the moon like the European Space Agency is proposing. So we don't need to necessarily go, but if we do, with something like Project Starshot, we need to send a swarm, because there's so many risks in travelling through the interstellar medium. You could hit dust grains that could destroy your spacecraft. So you'd want some kind of shotgun-like system where you send many, many hundreds of probes. So in short, I think it's promising. They've already got $100 million of funding. They would need to up that to about $10 billion or so in order to actually lead to an actual probe being sent. But I think there's good prospects there, and as always, I'm really optimistic and really pleased to see how many billionaires there are going into space exploration. A good example is Jeff Bezos, of course, the second richest man in the world. I think he's valued at about $66 billion. I mean, even more than SpaceX, he could just pay for Blue Origin to do whatever they want without having to worry about being profitable. So, I mean, the future is bright, so long as, because we have all these generations of billionaires who grew up reading science fiction like Isaac Asimov, Arthur C. Clarke, that now have been disappointed at not seeing us having the permanent bases on the moon we were promised in the 1960s and 70s. And so they've decided not just to sit idly by, but to actually do something about it. So I'll leave it there. I hope you've enjoyed this live stream. I've been quite pleased with how it's gone, so I will probably leave up this live stream just in its full form. Let me know any thoughts that you have in the comments down below or any future video suggestions. But for now, I will sign off, and maybe I'll see you again with a live stream like this, hopefully before we reach the 10,000 subscriber milestone, because I've quite enjoyed this, and it's always nice seeing what you would like to know and interacting with you. So, okay, bye for now, and see you on October 1st.